So my name is Nate, and welcome to another exciting G2G AI for Science event. We're supported by Google to bring you all the latest and greatest insights into AI tech and how you can apply those to basically accelerate your science. And so if you're not signed up to our community yet, I highly recommend it. If you want to be informed about any Google funding opportunities, there are 2 open calls at the moment on our site, the Digital Future Initiative and hosting a Kaggle competition. And we have this ever-expanding list of resources that can help you in your science, a bunch of different platforms, programs, and different opportunities as well. You can check those out if you are free. Yeah, we've got a whole host of events coming up and activities over the next few months, so be sure to sign up for anything interesting, covering a wide variety of domains and everything in between. Some hands-on, some are tech talks, and yeah, some are quite involved as well. So we are a community-led, I guess. We have a few community members on the call today, so that's great to see. Hi to them. Hopefully they'll jump into the chat if we have any troubles today. But yes, we are focused on fine-tuning our first AI language model. So that's where we're launching off, and it should be a bit of fun. We'll be working at a steady pace, but feel free to jump into the chat and ask any questions if you get stuck, or if something, if you need any insights into anything. And I can slow down and repeat myself, or hopefully other people can pick up the slack. Okay, so let me just, yeah, hopefully I've pinned that message in the chat, and everyone should be able to access that page. Now, there's a few little gotchas, I guess, throughout the course, but hopefully we'll sort of work them as we go. If you're not familiar with the Google Colab environment, it's basically a Python notebook in your browser that you can interact with, and it provides either GPU, TPU, or just CPU runtimes, they're called, in the background. And so this one today, or actually we'll be using a couple different ones, but the first one that we're going to use is a TPU. Sometimes that it may not immediately work for you, because you're basically using scavenger resources on the free tier of Google Colab, in which case you can try it in Kaggle as well. So there's Kaggle resources, which is sort of separate, but for that you need a verified mobile phone number. So just keep that in mind, and hopefully that'll sort of make sense as we go. Now, this is a read-only notebook at the moment. You can make edits to it, but it won't be saved. So if you want to sort of save your progress as you go, you can just click on either copy to drive, or go file and click save a copy in drive, and that'll sort of make a copy in your own directory. And you'll be able to modify this one as you see fit. So in fact, I'll work on my copied one. So I'm going to just close that runtime. Okay, good stuff. And here's my copy of it. And I'll just clean up my screen a bit. I'm going to minimize that, and so we have a bit more screen real estate. Fantastic. So today we're learning all about fine-tuning a large language model. So hopefully we've all had some experience with using some kind of large language model, maybe Gemini in the browser, or ChatGPT, is quite iconic. And perhaps you've used a language model sort of offline. And that's what we're going to be doing today. We're going to be pulling a large language model to our own device, or in this case to our Google Colab, but it works the same if you're running on your own device. And we're going to just tweak the model a little bit to provide it with new information, so it can perform a task that we want. Okay, so let's yeah, there's a bunch of preamble there. If you're interested, we'll sort of talk through a lot of this as we go. And where are we? Okay, so the very first thing we need to do, we need to go and get some data, and we need to go and get a model. So they're the 2 things that we're going to start with. And for this purpose, we are going to use Kaggle. So if you're not familiar with Kaggle, it is a platform for, basically it started out for data science competitions, but then it expanded out, and now it's a one-stop shop for getting large language models or data science models, machine learning models, and also big data sets as well that come in all different varieties. And as I mentioned, you can also run your own notebooks and code on there too. So yeah, so this is important. Everyone follow along. We'll need to go to Kaggle. Let me open it slowly. So I'll click on that. Yes, go to Kaggle. And I should point out, if you are using the Kaggle notebook, then you should be fine, and you won't need to actually do this because you're sort of in the Kaggle environment. Okay, and I'm going to click up on my icon there and go to settings. And in my settings here, you can see I've got phone verification. That means I can then access sort of higher level GPUs and TPUs if I want to use the Kaggle notebook. But down here is something called API. And this basically is just like a username and a password that lets us connect to Kaggle. And basically, any platform that you use, you're going to have to do this. So it's good just to sort of understand that this is the mechanism that, that basically all platforms sort of use it, and some come in slightly different ways. But I'll click create new token, and it's saying, are you sure this will expire the old one? It's no problem. So I've just got a download dialog box. I'm not sure if you can see that. So I've downloaded it. Let me go to my downloads. We can see it. So it just downloaded this thing called kaggle.json. I've got 5 of them. And I'll actually show it to you. But don't show anyone this because it is basically a username and password. It just looks like this. It's just plain text. We're going to use this username and this password, or you'll use your own username and password, and you should be good to go. The benefit of these API keys is that you can retire them. So I've just shared it with everyone on the call, so it's no longer secure. So I can just expire that token and create a new one. And so this one I won't share. Good stuff. So okay, so once you've got that, you're almost set to sort of go back to your notebook now. And there's one other thing that'll come up. The models that we're going to be using, you just have to accept the terms of service for them, and we can do that now, or you can do it later when it comes to it. If you see the error, but I'm just going to click on the Gemma model card, and it takes me to here, and it says here you've consented to the license for Gemma. And in fact, that might be the wrong link. I think we want Gemma 3, although it could be the same license. So models, Gemma 3. Yeah, so I've consented to that model too. So I'll just post that in the chat. And you can consent to that license. So a lot of models, they have different tiers of openness. Some are open without having to agree to any license. Some are closed. You can't access the model at all. And then others have sort of different open capabilities. This one, yes, Gemma 3, they have open model and open weights, but you just have to accept the license. Fantastic. So that'll come up if that we can overcome that later if it's an issue for anyone. All right, so now I'm going to run my first cell. So there's a few ways to do this in Google Colab. Probably the easiest, click the play button there, and the first one will take a little bit. It says it's connecting. Hopefully we get some resources. Sometimes as I mentioned, there are not any TPU or GPU resources available, so it sort of defaults you back to a CPU. It looks like it's worked for me though. So fantastic. It provided me this Kaggle login. And so now I'm going to just paste in those credentials that I downloaded before. And from there, we should be good to go. So post that, log in. And look at that, Kaggle credential set. Looks like you're Oh, that's okay. It's the warning saying I'm using an old version of Kaggle Hub, but Kaggle credentials successfully validated. Now, I think that's the hardest thing we'll do all day. So if we can all get through that, we're doing fantastic. And then while you're sort of experimenting with that as well, and people are posting in the chat if you have any trouble, I'm going to run the next cell as well. So I'll click play, and this will download all these all the models and data sets that we need today. So I mentioned we are using that seemed awfully quick, but that's okay. I think hopefully it worked. What I've just done, I've used this Kaggle Hub package to download models from Kaggle directly. If you're using the Kaggle notebook, you'll see that it's actually just embedded on the drive, and you can it's just a path on the drive. Now, if you were doing this offline on your own computer, all we're doing is someone could give this to you on a USB, could download it from somewhere else. The data set is basically just a CSV file, so there's nothing, there's nothing crazy going on. And so we've downloaded two models that we're going to use: the Gemma 3 Instruct 270M, and I'll talk about this in a second, GP2 base N, and also a data set called MedQuad. So yeah, hopefully they've downloaded for you. And the next thing we need to do is just update some of our environment. So I'm going to run this cell while I talk, because that one will take a moment. Now, this space, large language models and AI and everything, it's evolving really rapidly. And so if you've used Python much in the past, you'll know about like dependencies and package management, and it can be quite fraught with inconsistencies. As one thing updates packages, it might leave some old packages behind, and so getting the right balance of versions for all your packages that you're using can be very difficult. So hopefully this works. Even while I was developing the notebook, things sort of changed and new versions came out. So I've just fixed it at these two ones in particular. So we're using a package called JAX, and JAX is kind of like the powerhouse of all the deep learning that's happening in the background. It's doing all the sort of hard work. And if you haven't heard of JAX, there's you've probably heard of PyTorch or TensorFlow. So they're the three sort of major deep learning libraries in Python. And we're using the particular TPU version of JAX. So that means it gets the power of a TPU. And a TPU is just like a GPU, but it's made specifically for doing deep learning problems. So it's a tensor processing unit as opposed to a graphical processing unit, which is a GPU. Okay, cool. And Keras Hub is another site we're using. So Keras Hub, Keras is kind of like a library that makes things a lot easier than using the low-level JAX library. Keras sort of abstracts away a lot of the configuration and settings and lets us sort of use our model a bit easier. So we'll be using we're using this package called Keras Hub, and I won't go through the documentation too much, but yeah, it sort of builds out specific model workflows. So it's tied closely to the model that you're using, but Keras kind of does a lot of that work for you. But it supports quite a few. Okay, good stuff. Is there a reason we're not using UV instead of pip? Great question. So no, I guess I'm just really used to pip. I'm aware of UV, but I say this, I've said this before, that I've been using Python for a long time, and that can be a problem because I still have things I learned 15 years ago I still use today, and when I should be trying to keep up to date with more modern things. So pip is a way to install packages that we don't have. Yeah, UV is another one. All right, now any of these workflows that you come across, there's always like so many little knobs to tweak and things to press. We're setting two environment variables here. This one just sets the Keras backend to JAX, so it knows that it has to use JAX at the low level instead of PyTorch or TensorFlow. And then this weird looking environment variable also just says use all the TPU memory that's available. So you don't have to do that one. You probably don't even have to do that one and probably figure it out itself. But you'll see if you watch any other sort of YouTube videos or workflows on this, there's always like these little flags that you can set that improve performance or modify things just slightly. Some are required, some depend on the version you're using. It depends whether you're using GPUs, TPUs, or CPUs. It depends whether you're using JAX, PyTorch, TensorFlow, like what options are available. So it can be quite overwhelming. Okay. Next step, we now import JAX, and we also say, JAX, please use the TPU. So there we said, Keras, use JAX. And here we're saying, import JAX, and JAX use a TPU. Okay, so I'll run that, and hopefully that should work. And then we also import Keras Hub. And I don't think we actually need to import Keras. Oh, no, maybe we do. All right, and yeah, so there's another little flag that I've commented out, which can be used to improve the efficiency of your model training. But for demo purposes, we probably don't need to go into that. Okay. Yeah, so, oh yeah, thanks, David. Yeah, Keras isn't necessarily tied to JAX specifically. It tries to be agnostic to whatever framework you're using. Okay, cool. So now let's see if this works. So that's it. We've set ourselves up. As I mentioned, this will probably change depending on what if you use CPUs, GPUs, or TPUs, and what libraries you're using, and so what libraries you're using, and CPUs, TPUs, and GPUs. This initial setup will change. From here on, it's pretty consistent, I think, across anything. Okay. So next step, we are loading in our data set. So this is just a CSV file. I'll run that. Hopefully that works. Fantastic. Yeah, nothing too exciting about it. It is it's a medical question and answering data set. So it's basically a big data frame. So a pandas data frame of a question. Maybe I'll go look at it on the Kaggle website. It's a data frame that has a bunch of questions that are medically related. What is glaucoma? Glaucoma is a group of diseases that can damage the eye's optic nerve, etc. Then has where it came from, that question, and the focus area of it, and what causes glaucoma, and so on. So there's 15,000 or so questions and corresponding answers, and 5,000 unique focus areas. So that's our data set. Now, this is probably the it's quite important, I guess, to think about the data that we're using and what we want to do to train our model. So for this example, what we're going to do is fine-tune a general model to focus specifically on pernicious anemia. And so I'm kind of cheating a little bit, or maybe I'm not cheating, but I'm just pulling out every single mention of pernicious anemia within that data set and putting it into our data frame. And that's probably, yeah, it'll make our model, I guess, an expert in pernicious anemia. Hopefully that's or particularly in answering questions around pernicious anemia. Okay, so think about that when you're building a data set. Now, I find, yeah, this is glossed over in a lot of training, that the data that you can train on kind of like anything you want, but remember, it's basically a text model. So a large language model is a text model that knows about words, and it doesn't know about like numbers, but you can teach it to learn the structure of JSON formats, and you can teach it about pandas formats. But it loves, words mostly, or it's mostly built on that. And so any data set that you have, you kind of have to get it into the right format. And that's what we're going to do in the next step, is we have to build our data set into this sort of this object here that has prompts and then a prompt. So that was like a question that we'd ask the model, and then the response that the model will give us. Okay, so I'll just run that, and then we'll just have a look at it. I'll look at this formatted data, formatted data. Oops, formatted data. Okay, and it's just, basically it just becomes this. It's this massive dictionary here. So it's a dictionary of a list. So it's a 2-item dictionary that has prompts, and then it's just a massive list of input into the large language model, and followed by output of that large language model in the other prompt of the returned output. Okay, so I'm just dwelling on this because I've put it in this format particularly because I know the model that we're going to use next. But each model that you use, you have to put it in the format that the model accepts and expects for its input. And in case of the Gemma models, it expects prompts and responses in a dictionary format. So keep that in mind. And yeah, I think that's all I'll talk about at the moment. Won't do it on that too much. We'll hide that one. Cool. Okay. Any questions? Oh yeah, questions about the collab. Yeah, if you're running on if you can't get a TPU, yeah, you can try Kaggle. Or it should work. Most of this should just work on a CPU. I think, yeah. So most of it should work on a CPU. You might just have to change this line here, JAX config, change it to CPU, and then I think it should be, everything else should work okay. It'll just be slow. That's the problem. All right, so where are we? So loading the pre-trained model. Okay, so now I'm going to load this model. I'll run it while I talk. Okay, so it's loading this model from this thing I downloaded from Kaggle earlier, which is just it's just a path on the computer. So we can go and have a look at it. So it's Kaggle input Gemma. So let me just go and have a look at it. You know, there's nothing special. Kaggle input. There we go. There's the 3 things that I downloaded before. And this is what it looks like. So that's the actual model. It's got a bunch of JSON files which describe, you know, some of the parameters that are chosen in the model. And then I think the weights of the model is probably the large file that describes the kind of state of the model when after it had been trained. And we are using specifically a 270 million parameter version of Gemma 3. And that is this one. Where is it? Gemma 3. And let me go. Okay, I'm going to go back to this site here. I'll just post it in the chat again. And so like I've done this kind of through iteration. On the page here of Gemma 3, it describes, you know, a bit about the model, like how it works, the size of it, and the different variations of the model. So, and what it was trained on. So that's all interesting. And where we get down, and then it's benchmarks of how it performed. Okay, so at the bottom down here, it has this model variations on Kaggle. Now, we're using Keras, and we've picked Gemma 3 _ instruct 270M. Okay, but there's literally like hundreds of variations here. So if you were using PyTorch instead of Keras, you'd have to download the PyTorch version. And there's not the 270M model is not available yet on PyTorch in Kaggle. It needs someone to go and make that version. So you can take a model, you can load it in, and you can like refactor it and save it back out for the right framework. But they're all different. So you need to know ahead of time sort of what model am I using, what framework am I using. If you're using transformers, which is another one, we'll look at that in a second. Yeah, and then there's a whole bunch of others. And I'll just mention as well, so that they're generally named by the name of the model, and then underscore, and then 1B, 12B, 12B. means how big the model is. So anything over, sorry, any 1B or less, so 1 billion parameters or less, can fit on most computers, probably run on your CPU, okay. Anything bigger than that, then you start to go into like, you need like a dedicated GPU. And once you get to like 27B, it might fit on, you know, like really high-end gaming GPUs or specific deep learning GPUs. So they're the types of model that are available. And yeah, bigger, I'm just going to say bigger generally means better. But you can, smaller ones have specific use cases. And then also there's a few flavors here as well. So there's ones that are text and ones that don't have that text qualifier on there. So text means, for this particular model, it's a multimodal model. So it understands what images are. It was trained on images as well and text. But then they've got lighter weight versions of them that are just the text only models you can download. And then they have the instruct ones. So instruct means they were trained for question answering. So if you remember way back when large language models first came out, and if you think about what they actually are, they're just predictive text generators, let's say. So that they are just trying to predict what the next word is from some sort of input. But the instruct ones, they were specifically trained or fine-tuned on question answering sets. So if you ask a question, it'll respond back an answer. Whereas if you ask a question for a non-instruct one, it might just be a bit less coherent. It won't be an answer. It'll be more like a continuation of the sentence. Okay, and there's a few other things as well, possibly in the transformers models. There's these ones called quantized, and yeah, I think that's interesting. Yeah, so the quantized ones means they're basically smaller, so you trade off a bit of accuracy for size and versatility. So they're smaller, but their performance is comparable. Okay. All right, so yeah, it can be super confusing picking a model, but hopefully that's a bit of an introduction to how to pick one. So we're using the 270M model. I printed out, so you load it into this thing called causal LM, or whatever you want to call it model. And I just printed it out. The summary of it tells you all about this model. So it's the backbone here, 268 million parameters, which adds up to, it's called 270M model. And yeah, I think there's other bits. I don't know exactly what all these numbers, you know, what they all mean, but we'll keep that number in mind, because when we fine tune it, that will change. Okay, so now we can set a prompt. We can set a question for what we send to the model. Click run, and then I click generate. Now on a GPU, this should be or a TPU, it shouldn't take too long. On CPU, it might take a little bit longer, but it should work. So I say that inference, which is what we're doing now, we're just using the model, is cheap, but training is expensive. So training, you need a much bigger GPU or something. So that took 20 seconds or something. And you can see that it's a pretty like wild answer. What is pernicious anemia? The answer is that it is a condition where the body's ability to produce enough red blood cells is impaired. This can lead to a variety of fatigue, weakness, shortness, breath, and dizziness. Yeah, I don't know fully if that's the right answer, but then it just repeats itself again and again and again for some reason. So that often happens, especially with these sort of smaller models. They go a bit crazy. But once we fine tune it, maybe we can improve that a bit. Okay. So we have our model in memory now. And now to then train the model, there's so many different options and configurations we can make. But what we've done, we've loaded in this thing called Gemma 3, and it has two main components, or maybe three main components to each model. It has it has the backbone, which is kind of like the way, the way, sorry, no, it has the architecture. The architecture is the way that the model is designed. So that's actual code in like PyTorch or JAX that describes, the shape of the deep learning architecture. So the neural network. So that's the architecture. It has this thing called the tokenizer, and that translates words into like a tensor numerical representation, like a vector of numbers. So each unique token has a unique representation that's been tokenized. And so all models are different, right? All models have or most models have different architectures, different tokenizers. And then the third thing is that I think is important are the weights. And the weights are what have been fine-tuned or trained on the model. So that's, they've trained it for hours and hours or days and days or weeks and weeks to come up with the state of the model at the moment, where it knows its path through the neural network. So when you give it a prompt, like what is pernicious anemia, it can find the connections and give you the most likely answer based on that particular series of input tokens. Okay, so that's what's happening at the moment. Now we can go and tweak all these parameters and come up with a way to adjust the weights of our model to give new answers. And one efficient way to do this is using something called a low rank adaptation model. This is kind of like, it has the neural network, and then you like bolt on a secondary sort of smaller network there that changes those only like some parts of the model. So I'm going to run that basically does nothing, but it just enables this LoRa adapter, and it says that 72 weights are trainable and 236 are still not trainable. So that means we're not training the whole model, just a little portion of it. And then the next thing we need to do is compile the model into a state where it can be ready to be trained. And again, there's like dozens of options here. You can actually leave all these out and just use the defaults. We've got set a few here. So we've set an optimizer to find that determines like how it moves through the neural net, I guess, how big jumps are through the neural net to find local minimums and local optimums. And we set this value called a learning rate, which means how big those jumps are going to be. And then we can set a loss function, and that determines like how to score how correct it is or how wrong it is. And we can also track a certain accuracy, so a metric for measuring how well it's doing. Okay, so that should be instant, compiling the model done. All right, and now I'm going to click run on that. So here's the bit that takes a while. If you've got a CPU, it'll take a very, very long time. On a CPU, it should be much more speedy. And again, with the fitting function, we can set a few parameters here. I've just got 2 available, but if I go to I'm using this. Is there a fit method? Where's fit? Where's my fit method? Oops, fit. Oops. Get that fit. Console LLM. Fit. Let's see what options are available in there. Anyway, I always say, yeah, read the documentation and training APIs, customize what happens in fit. Okay, JAX. So yeah, there's hundreds, thousands of different permutations that you can do in each of the steps here. Let me go back. Which one was it? Okay, still going. Okay, yeah. So lots of options you can perform in the fit method. Lots of options you can perform in the compile method as well. And yeah, I don't know. We're still, there's research papers on what the best options are. There's whole research domains on what all the best options are. So that is an open question. The defaults usually do a pretty good job. Okay, and what you're looking for is so each step through the model, we are saying, start with what you've got, and now here are the pernicious anemia questions and pernicious anemia answers, and we're training the model, showing it these question and answer pairs, and each time it goes through, it does the best job at trying to fit the model to those question and answer pairs. And as you can see, what we want is for loss to reduce each time it goes through. Hopefully that should plateau. It's still pretty high, so actually I don't think it has done a great job. We might need to increase the batch size. Sometimes that can make it better or worse. Nevertheless, we can now do the exact same prompt again and have a look at how it performs. Okay. Well, thanks very much for answering questions in the chat while I'm doing this. Yeah, I don't know a good way to test the trade-off. I think I've got written down somewhere like, oh yeah, so here we ask the exact same prompt as for our newly fine-tuned model. The hope is that the answer will be closer to what we have trained the model to do. So it's not better, it's not more accurate, it's closer to what we've trained the model to do. Like that's what we're doing. You can say like, oh yeah, this model's better than that one, but like if you have a real specific task, then you have to provide data that will solve that task, I suppose. Okay, so this time we ask a question. Pernicious anemia is a condition in which the body doesn't produce enough of vitamin B12 in the body. From putting these notes together, I've learned this is the case. So this is good. The deficiency can occur in people who are not of average height, who have a history of pernicious anemia. Very good. And how's it caused? It's caused by this. Very good. And how's it treated? So it's come up with like these extra bits and pieces, and then it starts to go a bit wild at the end there and repeat itself. But I think this is a much more accurate answer to that question. So fantastic. So that's it. There's only like a couple steps to actually fine tune your model, but knowing sort of how the bits and pieces fit together, I think can empower you to do a better job. And you can see now, our total parameters has increased. This number has changed. This has changed. So we've actually modified the model, and then you can save it out if you want. Save it to disk. Calls it lm.save to preset, and you'll see that it should come out in, there we go, there's my model, and it kind of looks like the same structure as the model before, but you can take that and go and deploy it on your own work, or reload it each time you want to use it. So there you go. Well done, everyone. You've fine-tuned your very own model. And yeah, I haven't spoken about overfitting at all, so great question. Especially for this demo, I wanted to actually overfit it. So overfitting means basically you're tuning it to a very, very specific problem. So if I asked it about anything that wasn't related to pernicious anemia, it might now be like, I don't know anything about that. But before, it may have known, about more general things. So yeah, the trade-offs come in the parameters. Having a batch size of 1 is a good way to overfit things. So you want a bigger batch size, so each time you show the model like multiple different versions of question and answers instead of just a single question and answer at a time. And so that way it gets more sort of general information. And yeah, again, with the optimizers, the learning rate, if you make that bigger or smaller, that can change how overfit or underfit you might be. And yeah, all the other parameters in there. But all right, so that's great. So that's all the steps you need. Now, in as shortest time possible, and as few steps as possible, we can do it again, this time with a GP2 model, just to show you sort of the difference. If you didn't want to use Gemma or you wanted to use some other model, how does it change things? So again, we downloaded this one earlier. It's just a file on our disk now at Path GPT. I'm clobbering the Gemma model, and I'm loading the GPT-2 model in, which is fairly lightweight. I think it's similar to the, actually, let me look at the model card on tagging. GPT-2, this one. So it's 125 million parameter model. So yeah, that's super small compared to, the models today are sort of hundreds or in billions. All right, and so how does it go out of the box? It says, what is pernicious anemia? It's a condition in which blood in your body stops working and it becomes resistant to oxygen. That doesn't sound quite right, but it answered the question, I guess. Okay, importantly, this time when we format our data frame, so I've still got the data frame loaded in, it's different. So keep that in mind. It's very different. Instead of having a prompt response dictionary, now we just have a, wait, what does it look like? Looks like this. GPT-2, it's just a list of strings, basically. So it's just, it's strings, and that means the prompts, the prompt and response isn't a thing. It doesn't know the difference between the two, and so it's just showing it lots and lots of text. So keep that in mind as well. And so every model you get, you'll have to adjust your data to make sure it fits into what it expects in the model. Otherwise, you just get errors when you try and fit it. It'll say oh, that I was expecting something else here. And so you can normally figure it out. It's often buried in the model card as well somewhere. All right, and this time I'm compiling it. I'm not using a LoRa adapter, so I'm doing a full fine tuning, and then I fit it. And in my compilation step, I had no option, so I just used the default. So in absolutely 3 steps. So load in an original model, get your data into the right format, compile it, and fit it. 4 steps, and you can have a new model trained on your own data, which is cool. So we'll see if that one works. Yeah, absolutely. So Ben asked about would you how would you pick these parameters? So yeah, you do something like a grid search to find what models work best. And there's frameworks for testing your LLM. So you can validate are the answers that you're getting out what you expect and what you want, and so you can build these frameworks that then test it on the grid search, and so that way you might be getting a good score, but it may not be doing what you want. So but that exists. Yes. Can I write those 4 steps here? The 4 steps for here? Yeah, sure. So we'll load in the model. It's number 1. Can I do this? Load in model for that data. I'll leave that one out of there. Compile model and fit. Super. Let me just press enter and that will come up the chat. 1, 2, 3, 4. All right. So yeah, you see it takes a little bit to get going, but once it does the first 1 or 2 epochs, and then it's usually really quick. Okay, so I'll go on to the second notebook, and I've got 2 more notebooks. We might not get through them, but the second one is I might just talk through it. It's just using a different framework. So instead of using Keras, so yeah, I'm talking about the framework. So if people say framework, that can mean a few things. So the framework in this case might be the software package that you're using to train your model. And yeah, again, that can change how you fit how you fit everything together. Just want to see the answer for this one. 9 and 10, fantastic. And so once that fit, good job. So our loss was decreasing, which is good. If you've seen a loss curve before, yeah, it just looks like it should slowly decrease and then plateau eventually. And there we go. And it looks okay. Actually, this answer isn't very good. So maybe we had to train it for a lot longer, maybe quite a few more steps, or decrease the batch size or something to get it more accurate. It doesn't seem like that answer is equivalent to what we trained it on. Okay, so yeah, that's the medical question answering data set. Now, yeah, keep in mind, if you throw it like, actually in the next example, we can talk more about the data. So we've still got 15 minutes. You have to, going back to getting the data into the right format and thinking about like how your data looks like to begin with, and what data you have available and what you actually want to do with your model, can really determine sort of how you build out the pipeline. Okay. Okay, cool. So we'll go do that. Yeah, let's talk about that. Okay, so I'm going to open up the second one, fine tune with transformers. I'll open it in Kaggle just for something different. You can open it in Colab, and I might not. So I won't run this, but basically it does the same thing, but it uses transformers instead of Keras. So that's really the only difference between these two. And so that means we have to download a transformers model instead of the Keras model. So that's change number one. We load in a bunch of different libraries. We're using Torch as a backend now instead. And yeah, we're using this library called Transformers, which is, you can think of it equivalent to Keras. Transformers is probably the industry standard, but I find it far more, there's far more options to choose from. So makes it a little bit more involved. Okay, and then you load, just like before, you load in the model, but this time you have to load in the tokenizer. So I mentioned the tokenizer is the thing that chunks up your words into specific numerical representation that the model can understand. So you have to load that separately, even though it's exactly the same. So you load it from the same data folder that the weights live in as well. Okay, and then we load the actual model itself. All right, and then here when we load in our data as well, so you can load in your data set just like we did earlier, but this time we have to change, or we have to set the prompts into the right format that we did before. So we have to put the prompts into the format that that transformers along with the model expect. So and we have to tokenize it ourselves. So we have to change it from from letters and words into ones and zeros, basically. Okay, and then from there it's almost the same. So we I think, yeah. So then we start. We give it a prompt. We ask the question. We get a response. All right, and then here's the configuration. So this is like setting our parameters like we did for the Keras model. This time we just have to set a lot more sort of options, and the defaults aren't as user friendly, I guess. But we build this thing that sets us up to train. So like you can copy and paste this into whatever you need and tweak things as required, but it should work. And then you train it, and there we go. We train it, and then you get a model, and you can ask questions again. So that's transformers. Like I said, I just wanted to fly through that just to show you that this other framework exists. But when you use that framework, you have to use a model that's compatible with the framework. Like it's like using, you know, Google Docs or Microsoft Excel. Like you can load a Google Doc into a Microsoft Excel or something, Google Sheets into Microsoft Excel, but you have to change the formats, and sometimes things change a little bit, but it's basically the same. Okay, and now going back, now one I'd originally planned to do, but it actually changed between, you know, when I changed when I was planning on doing this and when it came out, is fine tuning like a Gemini model. So you can use like cloud to fine tune your models as well if you don't have the hardware yourself. And the tuning itself of something like a Gemini model is super easy, but you got to set up like all these permissions in Google Cloud, so that's quite involved. But yeah, the documentation is there for how to do it. If you wanted a really big model like Google Gemini, you know, which is one of the state-of-the-art ones, and they have built in all these other sort of features that aren't just language models. And yeah, so that exists, but you can't do it as easily anymore. You used to be able to just do it with the sort of the free AI Studio, but now you need to use the full Vertex AI to do it. So I'll leave that as an exercise. Okay, so I've got a few more minutes. I will show you through the RAG workflow as well. So let's go number 3. I'll open this one in Colab. And so RAG is often a great solution if you don't want to fine tune something, or if you don't have the resources to at your disposal. So if you don't have large GPUs or anything, you can use a Retrieval Augmented Generation workflow. I guess which can often, yeah, it's far more efficient and can be very useful in answering questions about your own data. So let me connect. This might say I've got changes of connecting. Cool, connected, good stuff. I'll just shut down. Oh no, that's all right. Okay, so for this one, oh, this is me signed in. This one we use Keras Hub, but we use a package called Sentence Transformers, which is built on the Transformers library. And Sentence Transformers, it's basically going to take all our documentation, our data set, and it's going to turn it into something that the model can understand. Okay, so again, like this one, like before, we can run through, we can log in, we import a few libraries. The other thing we're going to use is this cosine similarity. So the way the RAG workflow works is that you provide it a set of documents. In this case, this can be the MedQuad data set that we've got, and you provide it some context, and that could be the question, you know, what is pernicious anemia? And it will search all those documents for not just the keyword pernicious anemia, but it will find it uses sort of higher level connections or what are called embeddings to find associations between words. So anemia might be related to blood, you know, but if you search for anemia, it's never going to find the word blood. But in these embedding models, it knows that anemia and blood are probably very, very similar to each other. And so anything to do with blood, it will get pulled into your context and come and find similarity between these two concepts. All right, so I'll log in and I'll log in and download. So here I'm downloading 3 models again. I'm downloading our normal Gemma model, and then I'm downloading this other one called Paraphrase Mini LM. This is the embedding model. So this is the thing that puts that finds the connections between different words and concepts. Now there's a bunch of different embedding models, and they're quite lightweight compared to normal large language models. So they can run on CPUs pretty well. I think this is using a TPU, but it will work fine on a CPU as well. yeah, and most of those models are pretty performant. So keep that in mind. All right. Yeah, and in the interest of time, I'll just talk through it, sort of what it does. We get our data frame here into, we just load in the data frame, and we basically create a big list of all our question answer responses. But instead of that, it could be a whole PDF. It could be paragraphs in a document. It could be sentences in a document. There's lots of different ways to sort of what's called like chunk up your data in order to tokenize it later on. So you want to keep the context together. That's the important thing with RAG. And yeah, there's no easy, I guess, answer. But yeah, the documents, it's just one big list at the moment. But yeah, so there's no straightforward answer to like how should I chunk up my documents. Some people do it like a sentence at a time, but keep the previous sentence and the following sentence to keep context between them. You can do words, you can do it. HTML is really good because HTML has natural sort of breaks in it, and Markdown as well. Lots of different ways to combine text in your own data, or chunk it up in certain ways. But in this case, we've just chunked it into sort of the different question answer sets and called it documents. All right, and then we run, we start the embedding model. We create this vector store of these embeddings, and then you provide your context or your question to it, and it will search for anything related in that context, and it should pull out the most relevant chunks of text or relevant documents or relevant paragraphs, however you've chunked it up. And then from there, you take those chunks that you've gotten. So that's what we do there. We get the best chunks. In this case, I've said the first best chunk, most relevant chunk, and then we just we send it to the model along with our question. So that was a before question. So we said, using only information from the context below, answer the following question. So we have the question that we asked before, plus we also include the text chunks. And that's what a RAG workflow looks like. You just sort of pull in extra data and you send it in with the prompt. Then hopefully, if the model works well like that, it will give you a response from there. Okay, so that was a bit of a whirlwind for the RAG, but hopefully, you can see its power there, and possibly how it's sort of related to fine tuning as well, and how if you don't have the power, then RAG is a fantastic way to query your own documents instead of full fine tuning. You often don't need fine tuning. Fine tuning, I think, if you're doing sort of low level stuff, it often might just be to get things into like right formats. You have from this abstract, please pull out like these particular, get a conference abstract into a particular format or something. Anyway, there's much more reading to do if you want. There's a few YouTube videos in there as well I've included that sort of build on all of this. But if you have any questions, feel free to ask them. Otherwise, go and fine tune and let us know how you go.